Lesson 6.6 is on scale drawings. So I first want you to pause this and try these two warm-up problems on your own, and then we'll go through them together. The first warm-up problem says write a proportion, then solve. 18 donuts in 3 boxes, 30 donuts in B boxes. Okay, so the two things we're working with here are donuts and boxes. So I'm going to write my proportion as 18 donuts over 3 boxes and set that equal to 30 donuts over B boxes. Okay, it's important we stay consistent, so donuts over boxes equals donut over boxes. Then to solve this, what we want to do here is a few different things. You could cross multiply. What I see is that to get from 18 to 3, I divide by 6. So if I do that same thing on the right here, divide by 6, 30 divided by 6 would be 5. So 5 boxes. If you cross multiplied, you should have gotten that same answer. Number 2 says, Angie notices that for every 32 eggs her hen lays, 1 will be brown, while the rest are white. If Angie's hen produces 416 eggs, how many could Angie predict would be brown? Okay, so we have total amount of eggs, and we have brown eggs. So I'm going to do the total on top, 32 eggs over 1 brown egg, and set that equal to total over brown eggs. So the hen produces 416 eggs. We're going to figure out how many brown eggs there would be in that batch. So again, you could cross multiply, but here I see that 32, or actually I could do it this way, 32 divided by 32 is 1. So then I can take 416 divided by 32, and I get 13. So 13 brown eggs in that batch. Make sure that you add a label. If you were to use cross products, you should have gotten the same answer. So some vocab for today. A scale drawing is a two-dimensional drawing that is proportional to the object it represents. So that's the key here. It's proportional, right? So if we were to draw a scale or a scale drawing of the classroom, we'd have to measure it out so that all of the desks, everything in the classroom are proportional on the paper to as they are in real life. Scale model is pretty much the same. The only difference is that a model is three-dimensional, so 3D. So I'm sure you've seen like scale models of houses, or I know like some like doll houses are scale models. Everything's proportional. Scale is the ratio of a dimension on the drawing or model to the corresponding dimension on the actual object. Scales are written so that the unit length on the drawing or model is listed first. So we want that unit to be first. So different than unit rate where we had it on the bottom, we actually want the unit to be on the top. So like 1 inch equals 2 feet, or 1 inch colon 2 feet. 1 inch for every 2 feet. The biggest thing I want you to write down is this: model over actual. That's what we are going to do over and over and over to find the scale. So the first problem says a gardener is making a scale drawing of a garden. Okay, we know it's to scale. The length of the actual garden is 9 yards. The length of the garden in the drawing is 3 inches. Find the scale. So again, we're going to set this up doing model over actual. So model on the numerator is 3 inches, and it says the actual is 9 yards. Okay, model over actual, we want a 1 on the numerator, so I'm going to divide both of these by 3, and I'm left with 1 inch over 3 yards. You could also write it like this, 1 inch to 3 yards. So on your paper, every 1 inch is equivalent to 3 yards in real life. Okay, the next problem has to do with scale factor, which is a little bit different. It says if the scale drawing and model have the same units of measure, the scale can be written without units. That's called the scale factor. So here we just found the scale, and we had to leave the units in because they have different, right? Inch and yards, those are definitely different measurements. So 1 inch to every 3 yards. But this is saying if we have the same units, we can take those units off and call that the scale factor. So it says a model car is 4 inches long. The actual car is 12 feet long. Find the scale factor. So again, we're going to set this up model over actual. The model is 4 inches long, and the actual car is 12 feet long. So first, let's find the scale, and then we'll find the scale factor. So to find the scale, we need a 1 on the numerator. So I'm going to divide both of these by 4. And we're left with 1 inch over 3 feet. So for every 1 inch on the model, that's equivalent to 3 feet in real life. So to find the scale factor, we can convert these to both have the same units and then take those units off. So I know there's 12 inches in 1 foot. So there's 36 inches in 3 feet. So I'm going to write this as 1 over 36. So that's with the same unit. So that's called a scale factor. Okay, this one says the distance on a map from Toronto, Canada to Ottawa, Canada is 9 centimeters. The scale is 1 centimeter for every 25 miles. What is the actual distance between the two cities? Set up and solve a proportion. So we're going to solve this model over actual. Anytime we're working with scale, model over actual. So the first part says the distance on the map is 9 centimeters, so that would be the model. We're trying to find the actual distance in real life, and we know the scale is 1 centimeters over 25 miles. So this tells us, right, when we set up a proportion, if we have centimeters over miles, we know on the left side it has to also be centimeters over miles. So my label is going to be miles. Okay, you could cross multiply to solve this. Really, whatever works best. We can also do it this way. 1 times 25 gets us to 25. So I multiply 9 by 25. And 9 times 25 is 225. And then we label that as miles. So 9 centimeters on the map, in real life, that represents 225 miles. Okay, this one says find the dimension of a scale model. So it says the model of a building has a scale factor of 1 to 40. The building is 100 feet tall. Find the height of the model. So again, whenever we're working with scale or scale factor, model over actual. Okay, here the scale factor is 1 to 40, which tells me that they both have the same units. Okay, so I'm going to write this as 1 over 40. And then it says the building is 100 feet tall. Find the height of the model. So the actual is 100 feet. The model, we don't know. Okay, to solve this, I'm going to solve this using cross multiplying. 1 times 100 is 100. 40 times x is 40x. Then I'm going to divide both sides by 40. And I'm left with 2.5 equals x. So we know that the scale factor has the same units. which means that our representation, our model here has to have that same unit. So this is actually going to be feet. Since the actual was feet and we're working with scale factor, the model is going to be out of feet as well. This one says Sheila is designing a patio that is 16 feet long and 14 feet wide. Find the length and the width of the patio on the model. Use a scale of 0.5 inches equals 4 feet. So we're working with scale, model over actual. So we know that the scale is 0.5 inches over 4 feet. We know that the patio is 16 feet long and 14 feet wide. We're trying to find the length and the width. So we actually have to set up two separate proportions here. Let's start first with the length. So this one will be for the length. So we have our scale there, and then we know it's 16 feet long. So that's in real life. So that's the actual 16 feet over. We're gonna figure out how many inches that is on the model. Okay, and again, we still see this consistency in this proportion, inches over feet, inches over feet. We can cross multiply, we can multiply up and down. What I'm gonna do here is I see that on the denominators, 4 times 4 is 16. So I'm gonna do that same thing to the numerators. I'm gonna multiply 0.5 by 4, and that would be 2. So the length equals 2 inches. Remembering that my model is represented in inches. Then we have to find the width. So I'm going to set up another proportion for the width. And I'm going to keep my scale 0.5 inches over 4 feet. And again, model over actual. So the patio is 14 feet wide. That's the actual. We're trying to find the model. How many inches is it on the model? All right, here's what I'm going to do. I'm going to cross multiply to solve this. 4 times x is 4x. 14 times 0.5 is 7. Divide both sides by 4. And I'm left with the width is 1.75 inches. Okay, so the length is 2 inches, the width is 1.75 inches. And this should make sense because in our actual patio, the length was longer than the width, so it should be the same in our model. The length is a little bit longer than the width. Okay, a few review problems. This one says a map uses the scale of 1.5 centimeters equals 25 miles. Two cities are 190 miles apart. How far apart are the cities on the map? Okay, to solve this, we're going to set up a proportion using model over actual. We know that the scale is 1.5 centimeters over 25 miles. And we're told that two cities are 190 miles apart. So that's the actual. That's going to go on the denominator. And we're going to figure out how many centimeters that is on the map. To solve this, I'm going to cross multiply. 25 times x is 25x equals, and then I take 1.5 times 190, and I get 285. Then to solve for x, I'm going to divide both sides by 25 so that we can get x by itself. And I'm left with x equals 11.4 centimeters. So B is the correct answer. Okay, this one says an architect drew the blueprint for a new office building. He used a scale in which 1 inch represents 7.5 feet. The floor of an office in the building will have actual dimensions of 18 feet by 24 feet. What will be the dimensions on the blueprint? Okay, so again, this is like a double one where we have to find that length and the width. So let's start first. We know we have to do model over actual. Let's set up our proportion. We have 1 inch is the model over 7.5 feet in real life. Set that equal to, we'll start with the 18 feet. So it's actually 18 feet. We're figuring out what that would be on the model. To solve, I'm going to cross multiply. 18 times 1 is 18 equals 7.5 times x is 7.5x. Divide both sides by 7.5. And I'm left with x equals 2.4. And remember, our model was in inches, so 2.4 inches. Well, the nice thing about this problem is that we already have only one answer with 2.4, so we know it's going to be A. It's always a good idea on tests like this, though, to just double check to do that second one of 24 feet, just to make sure that you get 3.2 inches. That would be a really easy way to guarantee that you're getting the correct answer. Okay, let's do one more. So this says Marcel's drawing of an ant is 4.5 inches long. His drawing is 12 times the ant's actual size. How long is the ant? So we know the drawing is 4.5. Okay. Then, using our model over actual, the actual is 12 times that length. Oh, wait. No. The actual is 12 times smaller than that, right? Because if we had 4.5 inches long for an ant times 12, that would be like the biggest, scariest ant that I've ever seen in my life. So 4.5 inches long is way bigger than a normal ant. Okay, so you have 4.5 inches long on your paper. We're going to find the actual size, and it says his drawing is 12 times the ant's actual size. So we're going to divide this by 12 to figure out the ant's actual size. So I'm going to take 4.5 divided by 12, and I get 0.375. Okay, but here's the problem. We have options that are in fractions. So let's use process of elimination for this. 1/3, we know that one is 0.3 repeating, so it's not that. 3/8 could be. 1/2 is 0.5, so nope, can't be that. And 8/3, well, that's bigger than 2, right? So that's larger than 2, because 3 goes into 8 2 times, so it can't be that. So just by process of elimination, we know that it has to be letter B.